My name's Arzhang Ardavan. I'm a physicist at the University of Oxford, and I'm going to tell you about a program which promises to change the landscape of our modern current technologies by implementing molecular components as the building blocks. So over the last 50 or 60 years, we've witnessed a transformation of our information technologies associated with the miniaturization and the integration of silicon componentry. But as we just heard, that's reaching its limits, and there are some serious problems that silicon is not addressing. First, it uses a lot of power, and being able to reduce the power by some orders of magnitude, as is promised by the basic physics of two-level systems, would have huge benefits. But perhaps more importantly, key problems like machine learning and quantum information are extremely inefficiently implemented in classical binary logic. And so what we really need to do is be thinking about new hardwares, as we just heard, for embodying the classes of information and the kinds of algorithms that we're trying to work with in these information problems. And so the thesis of the program has two parts. The first is that by moving to molecular components, we reach the ultimate limit of miniaturization, but we also arrive at a possibility for rich functionality at the component level. And this gives us a range of hardware opportunities for addressing these key problems that we face. The second part of the program thesis is that now is the time to be thinking about this. And the reason is that what has held up the deployment of molecular componentry in the past is the lack of a methodology for building complex integrated structures out of molecular components. And what's really exciting right now is that such a toolkit is just emerging, co-opted from developments in synthetic biology. DNA nanotechnology gives us the toolkit for building things at this scale. So this is why right now is the time to be thinking about this. So in the in-depth session, I will present a program that has three themes. They're designed to kickstart the adoption of molecular components and to build a virtuous circle of research and deployment and reinvestment in research. And the program has a theme to make some technology demonstrators to show the world what can be done with molecular componentry. It has some activities to develop the market, to help translation, and to socialize problem holders to the kinds of solutions that this program might provide them. And the third theme is to generalize from DNA to a broader range of molecular assembly architectures. And I'll just leave you with the thought that if we can pull this off, it will be as significant for our technology landscape as the transition from vacuum tubes to transistors was in the middle of the last century. So please come and hear all about it later this afternoon.